So when we're talking about graphs, there are discrete functions and there are continuous functions. Discrete functions are like dot plots. This is discrete. And the word discrete just means singular pieces, like chunks, right? A continuous function, it looks something like this. It's got a nice smooth graph. We might start out with just some discrete points, but then we connect all the dots together. That is continuous. So that's a classification there. What we're looking at a relationship, it's either going to be discrete or continuous. So we just have to think about what the scenario is. Like if you're talking about the height of a tomato plant that you measure every morning, well, you only measure it every morning. You're not constantly measuring it, so it's a discrete. If you have GPS in a car, it is constantly measuring your location, so there's a graph that it's able to make of what it is, because you don't like magically jump from one spot to the next in a car. It might only measure 2 spots every 5 seconds or something, but it knows that you had to move in between them, so it draws a line between those 2 points. And that's the difference between discrete and continuous. We're going to draw a graph here based on this scenario, and then we're going to answer some questions based on that. So at an ice sculpting competition, each sculpture's height was measured to make sure it was within the regulated range of 0 to 6 feet. The measurement were as follows. Team 1, 4 feet. Team 2, 4.5 feet. Team 3, 3.2 feet. Team 4, 5.1. And Team 5 is 4.8. I just read a bunch of numbers there. I didn't even really need to read it. I just know it's going to give me a bunch of teams and heights. So what I'm going to do is the first one here is I'm going to make a table of values showing the relationship between the ice sculpting team and the height of their sculptures. Now, they were really nice, and they give each one of those teams very easy names to remember because they're numbers. So we got team 1, 2, 3, 4, and 5. And then we were going to have height of sculpture for each one of them. Team 1 was 4 feet. Team 2 was 4.5. Team 3 was 3.2. Team 4 is 5.1. And Team 5 is 4.8. So there is my table of values representing the team and the height of the sculptures. And you might want to put things down here like this is feet for height, just so you remember later on. Because now we've got all that stuff that's highlighted in pink and a much more condensed version of information. Determine the domain and range of the function. The domain is going to be the inputs, and that's going to be the team. Like, if I'm a judge at this thing, I'm not going to say who has a height of 5.1 feet, because no one might. But I care about which team it is. What's the height of team 1's feet? 4 feet. Yes, that fits the category. So team is our inputs, or our domain. So we're going to write D, and you can use capital D and capital R for domain and range. I don't mind that little shortcut there. The domain is 1, 2, 3, 4, and 5. The range is, let's put it in order, 3.2, 4, 4.5, 4.8, and 5.1. So you can see the domain and range don't have to be in the same order, because in sets we like the numbers to be in order from smallest to largest, or most negative to most positive if there's negative numbers in there. Alright, we're going to write the data set as a set of ordered pairs, then graph the data. So I'm just going to match up each one of these columns here in my table and make that an ordered pair. So 1, 4, 2, 3. Oh, sorry, that's not right. 2 comma 4.5, and 3 comma 3.2, 4 comma 5.1, and 5 comma 4.8. And now I need to graph the data. So let me grab my little axes here, and I might, you know what? Since I know all the numbers are positive, I'm actually going to just grab the positive version of the x and y axis here. There we go. So here we got team, and here we have height in feet. So team 1 was 4 feet. So 1, 2, 3, 4 feet. Team 2 is 4.5 feet. Team 3 was 3.2, so it's going to draw a little bit closer to that 3 line. Team 4 is 5.1, just a little bit above the line there. And Team 5 is 4.8, so a little bit short there. And there we go. There is our graph. Last thing, just state whether the function is discrete or continuous. Explain your reasoning. For this, I'm going to call it discrete. And the reason is the teams are building separate sculptures. So there's no connection between each person's sculpture, right? If there was a reason to connect the dots, then it could be continuous. So here I'm going to say this function is discrete because, and this is where the explanation comes in, there is no reason for the sculptures, how about with a P instead of a T for sculptures to be connected. All right. So there's no reason for a line to connect between those two things.